Oh yeah, 10.2 histograms. This is part 2. How do I analyze histograms? Okay, what's the point of data displays like stem and leaf plots and histograms? Well, they're to be analyzed. So the histogram shows the winning speeds, how fast the cars were going in the Daytona 500, which is 500 laps. Which intervals, hopefully you know what those are. They're on the bottom of the histogram. They're all the same size. Contains the most data values. So part A is which interval contains the most data values. I'm going to go ahead and put part A over here. And which one does? Which interval does have the most data values? This interval looks like it may have about 1. The interval 130 to 139 has 4. The interval 140 to 149 has between 12 and 16, maybe 14. And between 150 and 159 looks like it's about 19. And then 160 to 169 is about 7. And then 170 to 179, that's maybe about 6. It's hard to say. Something maybe 5 actually. So which one is the most? Well, isn't it obvious by looking at this? Can't you see that this one right here has the highest frequency? So which interval contains the most data? It'd be 150 to 159, and this is in miles per hour, so I'm going to put mph. Okay, now going to part B, and I'm going to put a little period there. Didn't work very well. Oh, that's a beautiful period. Okay, so this says now, how many of the winning speeds are less than 140 miles per hour? Well, here's 140. So where's less than? To the left or to the right? And of course, numbers to the left on the number line are less. So if we're asking how many of the winning speeds are less than 140 miles per hour, we're looking for the frequency. Well, there's 2 different bars that are less than 140. So how many speeds were recorded between 130 and 139? 4. How many speeds between 120 and 129? Looks like just 1. So how many are less than 140? 5. 5 winning speeds. Yeah. Okay, now on to C. And C says, notice I'm just doing this one at a time. Just one at a time, I can answer each of those questions. How many? Okay, as soon as it says how many, are we talking about speed or are we talking about frequency? I hope that you're already seeing, oh, frequency is your how many on a histogram. How many winning speeds are at least 160 miles per hour? At least means greater than or equal to. That means greater than or equal to 160. Isn't that on this side? So it would be this bar and this bar, right? Well, how many speeds are here? That's about 7. And this one, I think we said was about 5. I could be wrong. Maybe it's 6, but let's say it's 7 and 5. So that together, if I find their sum, that's 12 winning speeds. Okay. Less than means to the which direction from 140 to the left of 140 on the interval? To the left, to the left. Okay, at least means greater than or equal to 160. Cool, we are rocking this. We've already gotten this one done. You know, whenever you're doing these videos, you can watch them over and over and over again because there's nothing to stop you and it can help you. So let's do it. Last example, question, how do I compare histograms to pie charts? Okay, the big overarching idea here is that we're using data displays. This is statistics. We have data displays. We just learned about this one. Do you remember what it's called, or did you already forget? A histogram. It's the title of the section. And this one is a pie chart, which you've probably seen before at some point. And don't forget, we also have learned about the stem and leaf plots. So there's 3 different data displays. But this says the data displays show how many push-ups students in a class completed for a physical fitness test. which data display, now if it says which, that means we have a choice between one or the other, can you use to find how many students are in the class? And then explain. How many? Wait, we just talked about this in the last question. Whenever it asks how many, are we talking about the intervals or the frequency? We're talking about frequency. Well, does a histogram tell you what the frequency is? Does it tell you how many people are in each of these different intervals? Yes. Even though we can't make the data set because we don't know, we know there were 3 people who got 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. We don't know which of those they got, but we know there was 3 of them. So we know we can use the histogram. It tells you frequency. So whenever you're asked how many, it's the same as asking what is the frequency. So we know we can use the histogram. Maybe we could use the pie chart too. Let's look at the pie chart. So it says 0 to 9 was 3 people. That's the frequency. Well, 0 to 9 here says 12%. Huh. 12%. The problem with percentages is, we'll go over this. Let's say I said, great job. My first period class, 100% of the students got an A. Would you be able to tell me how many students are in the class? No. All you know is that all of them got an A. You don't know how many students there were. So whenever we have percentages, it's not going to tell us the frequency. You cannot use a, what's this thing called again? It's called a pie chart. Pie sounds good right now, by the way. Okay, pie chart. Because it only has the blanks. Does it have frequency? No, it has percentages. Or yeah, we'll use percentages. And I don't know if I'm going to be able to have the space. Will he do it? I think he can. Oh, look at that. No problem. Percentages rather than the, when we say how many, when we want to know how many, we need the frequency. You might say the frequency of jokes in Mr. Plunkett's videos is way too low. He needs to have more of them. Anyways, overall idea, how can we display our data using intervals? As you can see, we can use a histogram. Thank you all. You are all amazing. I hope you're all doing well out there. I miss being in class with you, but keep it very, very real.